So hello everyone, this is Himabindu from the Department of CSIT. Today in this video I would like to explain about the introduction to the regular grammars. Till now we have seen that what is meant by regular expressions, what is meant by regular languages, and how we are forming the regular sets, and how to convert the regular expressions to a regular finite automata. And these concepts are already discussed. And now what is the mean by grammar and how to form a grammar into a regular grammar. And we'll move to the slides. What is meant by grammar? Grammar is a theory of grammar in the theory of computation is a finite set of formal rules that are generated syntactically correct sentences. So here by using the grammars we can form this language is with the rules, formal rules that are generating syntactically correct sentences. We can form the correct sentences in the given languages. And what are the grammars? How many types of grammars in this theory of computation? So here in the first videos we discussed about what is the type 1 language, type 2, the type 3 languages, and here we will also discuss about the languages type 3. So we are discussing about language regular, and with that what is the automata for that regular languages. So here finite state automata, and what are the production rules for this type of language, regular language with the automata. So here are the production rules. We have to form this kind of rules for the given regular languages. So, and this type 3 is the language for the regular languages. We named some grammar type. So here all the some types of grammars. Type 0 grammar is about the recursive enumerable language, and we are using the automata called Turing machines, and there is no restriction of production rules in the type 0 grammar. And type 1 grammar, it is a context sensitive grammar. And what is the automata we are using in this type of grammar? In the sense, it is a non-linear bound automata and non-linear deterministic, non-bounded, non-deterministic machine. And here is the some production rules where we are using in this type of type 1 grammar. And type 2 grammar is about the context, which languages we are using in this type of grammars. In the sense, context free grammars we are using. Context free languages. Next we will discuss about the context free languages, and this context free languages, and what is the automata we are using for this type of grammars. In the sense, non-deterministic push down automata, and these are the rules, production rules to use this type of grammar. And what is our concept? The type 3 is what we are discussing. Till now we have discussed about the regular languages. So this type of regular languages, which type of grammar we are using? So it comes under the type 3 grammar. And what is for this type 3 grammar, what is the language? In the sense, it is a regular language. And what are the finite automata? In the sense, we already have this with output and without output, output and without output. So we have the finite state automata. So without Moore and Millet, Moore, Millet. And here we have 3 types of automata. So one is DFA and NFA and epsilon NFA. So these finite automata missions, so which are used for this type 3 grammar. And what are the production rules? So we will discuss about this in the next slides. So how to form these production rules, and what are the production rules having with the linear grammar, like linear grammar, like this. This is about what is meant by grammar. So grammar in theory of computation is a finite set of formal rules. So it is a finite set of formal rules that are generating syntactically correct sentences. And here we have the four types of grammars. So here we are discussing now about the type 3 grammar, that is the language forming with the language, regular language and finite automata, and these are the production rules. And here the diagram represents the type of grammar in theory of competition. So here what is the grammars? The recursive enumerable language grammar, and context sensitive grammar, and next it's in context free grammars, and next to regular languages, regular grammar. So these are the four types of grammar till now what we have discussed in the previous slide. So it is how we are going to look like in the grammars wise. So type 3, this is the type 3 grammar, and this is type 2, and this is type 1 and 0. There is a no restriction of production rules which is in the recursive enumerable language or in recursive enumerable grammar. And let's define this, what is meant by grammar. So the formal definition of grammar is that it is defined as a four tuple. So till now we have seen that it is having the finite automata which is having the 5 tuple. So and in Murray and Milley missions it is having the 6 tuple. So what is this tuple means? It is a form of language which is formed by all these tuples. So here also grammar, we are using this grammar, especially we are using this grammar, and what is this grammar contains, and what are the how many tuples we have in the grammar. So here the four types of grammar things are there. What are those four tuples? So V is a finite set of non-terminal symbols which are denoted by the capital letters, and T is the terminal symbol, finite terminal symbols, and P is the production rules, and S is the starting state. So let me revise one more time. So V is a finite set of states. So here V is a finite set of state. It is denoted by the capital letters. And when comparing with the finite automata, it is belongs to the Q. So it is having the states, how many states, like Q0, Q2, like that. Here it is like a terminals, finite set of non-terminal symbols are nothing but like S, A, B, which are denoted by the capital letters. And T is the final set of terminal symbols which are belongs to the input symbols. We can say that it is A, B, so which are denoted by the lowercase letters. And we will discuss it with the example more clear. And P is the production rules. So how to form a production rule in the sense. So here it is left side only one terminal, when non-terminal is there, that is a V, and here it's a combination of terminal and non-terminal. So here V union U. So here V union T. So V union T. So it is a form of, so V belongs to V union T. So it is a combination of terminals and non-terminals. So here the production rule which is formed in the union of left side, it is having the non-terminal set and non-terminal, and the right side it is having the combination of non-terminal and terminals. And these are the examples of production rules. And here A and B are the non-terminals, and the small x is denoted by the terminal symbols. And S is a start symbol used to derive the string. So here the S is the start state to derive the string. And here what is the example we have taken? So G is represented as a grammar, and the grammar contains a 4 tuple. So 4 tuple, what is that 4 tuple? Here capital letters which are denoted, non-terminals which are denoted by the V, and here let me write. So V is equal to, it's a non-terminal set, so which are denoted by the capital letters, and here the A, B is the terminal, so we'll write it as a T, capital T. And what are the non-terminals we have? So which are like input symbols. And here the start state is S, and Here also status state is S. And what is the production rules? So here we have the production rules. So S tends to AB, and here A tends to A, and B tends to B. So here these are the production rules. By these production rules we can form a strings. So we can form a language. How we have to derive this production rule, derive the language from this production rules, in the sense we have to substitute all the values. Derivation. So this is about the derivation. So how to derive, in the sense we have to substitute the values. What are the production rules given? So with that production rules we can form a language. So we will substitute A tends to A, and here A tends to A, and here B tends to B, we will substitute. So what we get? B. So this is the language or a string which are formed by these production rules. So this is how we have to state that a grammar, given grammar, it is having the 4 tuple. So in that 4 tuple, V is the non-terminal set, and T is the terminals, and P is the production rules, and S is the starting terminal, starting symbol, which are used to form a string. And next slide. So what is meant by regular grammar? So till now we have discussed only about the grammar. So what is the grammar contains? It is a 4 tuple. So like this here also with the we have 4 types of grammar. So for that one, in the first one is about the type 3 grammar. So type 3 grammar is a regular grammar. So if this is the regular grammar, so generates a regular language. So by using this regular grammar we can form a regular language. So they have their single non-terminal on the left hand side, and right hand side it is consisting of a single terminal or a single terminal followed by the non-terminal. So just now we discussed the production. This is about the production rules. So production rules, left side it is having the single non-terminal. So that let me S is the single non-terminal, and it is a combination of single terminal followed by the non-terminal. So that is nothing but S or, and here one more combination, only a terminal. So only terminal 1, 2, and it is having a terminal and followed by non-terminal. So this is terminal, non-terminal V. So this is how we have to form a production rules for the given regular grammar also. So here, what are the types of grammars we have in the regular grammar? So we have the left linear grammar and right linear grammar. So which is denoted by LLG and or LG. So left linear grammar is denoted by left LLG, and right linear grammar. So there is a differences between these two grammars. So let me discuss. So here the left linear grammar, in the production rules are in the form of, all the productions are of the form like this. So there is both two grammars, it is having some differences. What are the difference? In the sense it is difference in the only production rules. So here the production rules, so left side it is common for both the two productions like left linear grammar and right linear grammar, and here it is a terminal, so terminal and non-terminal combination. So in the coming to the left linear grammar, the non-terminal is followed by terminal. So this is the left linear grammar, and here this non-terminal, left side it is always non-terminal, and it is non-terminal is followed by terminal is followed by non-terminal. So this is how. So there is a difference of left linear grammar and right linear grammar. So in the production rules, the left side is both, it is having the two production rules. So it is a production rules which is having the B, X and X. So two terminals, one non-terminal and one terminal is there. So in the production 1, it is having the combination of both terminal and non-terminal. So in the left linear grammar, we will say that non-terminal is first and followed by the terminal. Non-terminal is followed by terminal. And here in the right linear grammar, the terminal is followed by the non-terminal. So why? Because right side, so terminals are all right side here, and here the terminals are all left side. Non-terminals are all left side. Non-terminals are all right side. So this is how we have differentiating this left linear grammar and right linear grammar. And next, so derivation from a grammar. So we will derive a language from the given grammar. So here we are taking the set of all the strings that can be derived from a grammar is said to be a language generated from that grammar. So for this one, we have to take in examples, like we have taken 3 examples. For this, we will form a regular language by using this grammar, given grammar. So here we are taking the one grammar. So it is having the V. Let me write V is equal to, for the given grammar example. So we have to divide that Z into a 4 tuple. So 4 tuple is having the V, T, S, P. So V is a non-terminal set, and T is the terminal set, and S is the starting state, and P is the production rules. So for this one, we will write this 4 tuple. So V is equal to, so it is having the non-terminal set S, A, B, and so terminal set, it is having A, comma B, and so S and S is equal to S, and these are the production rules. So production rules are S tends to A, B, and A, capital A tends to A, B, and A tends to epsilon. So these are the production rules. Let me derive a language from the given grammar. How to derive, in the sense, first we have to start with the starting state. So starting state is S, and we have to start, and we have to take the production rule, and here we have to substitute all values. So here A. So here A, we will substitute A in the sense of A, capital A, B. So here we have to substitute A, B, and this is substituted, and B. So here we are, after this one, what is that? So A, B, B. And again we will write A is equal to capital A is equal to A, B. In the same equation, we will get A. So it is this A. So we have to write A by substituting A value. And what is the one more production? A belongs to epsilon. We will substitute this one. So here A, epsilon, B. So after removing epsilon, we will get A, B. So this is the language formed by this given regular grammar. So here is the language. We can say that this language which is formed by this production rules. Here is the language. L is equal to A, B. And next, one more language we have to take. So A is here we have to write the production rules. So tuple V, T, S, P. So V is equal to here S, A, B, and T is equal to A, B, and here the S is equal to S, and with the production rules are S tends to AB, and A tends to A, and B tends to B. So to derive the equation, to derive the language from the given grammar, first starting state we have to take AB. We have to substitute A value. So A tends to A we are substituting. So A and B. And here we have to substitute B value also B. So we will get the string AB, and which is the language by using this production rules. So language for the given grammar 2. So here also we will write language for the given grammar 1 is grammar 2 is A comma AB. And this is how we are deriving the grammar. We are deriving the language from the given grammar. And one more example. So here, so let me write the tuple for this grammar. So what are the tuple? V, P, S, T. So here V is equal to S, A, B, and T is equal to terminals A comma B, and S is production rules. S is equal to S, and what are the production rules? So S tends to AB, A tends to A, capital A, and slash A. So for the same non-terminal symbols, we have the two productions. So we can also divide this into A tends to A, comma A tends to A, and one more production, B tends to B, comma B, and we will divide this B tends to B, comma B tends to B. And here these are the example, these are the production rules. So first, how to derive, in the sense we have to take this starting state. So starting state to A, B. So first step what we have to do, in the sense we have to start with A, capital A. So instead of A, we will write A tends to A. And we will also substitute A tends to. So here are the equation. We have the we can form three types. So here we will divide this into three parts. So we have three production rules, and which is having for the same input non-terminal, we have two types. So we have to form this kind. So and here what we have substituted, instead of A tends to A, we have substituted. And here if you substitute A tends to A and B tends to B, this is what we will get, A, B. And for the same starting state A, B, if you substitute A, and B, and A tends to A, and here after B tends to B, so what we will get, A, B, B. And here after substituting this one, so here A tends to A and B tends to B, we will get A, B, B. So this is also one language, this is also one string from the same production rules. And one more, A, B. So here what we have to do, we will just substitute B here. B instead of B tends to B. So A is equal to A. We are substituting these values. A, sorry, B, B. So B, and here we, after substituting B is equal, B tends to B, we get B. So by using all this, so we have AAB and ABA, BB and ABB. So we will write the language of this grammar. So first AAB, here we have to substitute AAB. Or after deriving all the grammars, we have to get the terminal symbols only. If there is a non-terminal symbol in this one, we have to derive the one more production rule also. A, B, B, and A, B, B, and so on. So we will write represent A square B, comma A square B square A B square, and here. So by deriving all this equation, all these strings, we will also write A power M B power N. So here A power M and B power N, we will represent M power M greater than or equal to 0 and N greater than or equal to 0. So there is always it is having at least one A and one B. So we will write it as a M greater than or equal to 0 and N greater than or equal to 0. So this is the language which is formed from the given grammar. So this is how we have derived a language from the given grammar. So grammar is having the 4 tuples. So 4 tuple. In that one we have the production rules. Based on the production rules, we have to derive the language from the given grammar. And these are the references. So this is about the regular grammar. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.